Afternoon, guys. Welcome back to the channel. My name is Tinashe. I'm your host. This is the third episode. Thank you for subscribing. For those who haven't subscribed, please do subscribe. We need your support. We'll be very grateful. So today's episode. This is episode number 3. We're getting more into construction survey now. So where we're going to start is in construction survey. What are the roles/tasks of the surveyor or the setting out engineer? So, like I said before, civil engineering guys can also work as setting out engineers as well. Geomatics guys, setting out engineers as well. Surveyors, same thing. There's an interchangeability of roles there. You just pick what you like. So the roles, let me get to the serious business now. The roles tasks. So all setting out, all leveling, volumetric calculations, that's your baby. So every time something has to be done that needs setting out, leveling, volumetric calculations, it's your baby. There's also topographical maps and utility maps. Let's say you get onto a new site. You do a topographical map of what's there, and then you do a utility map. Let's say underground services of everything that's on that site, so that when people commence with the work, they know what's where. For example, you have cases of electrical cables. You can have a transformer box at the other end, or anything that shows an existence of electrical. You can actually connect them and determine the path of that utility. Might it be internet cables, anything that's underground, you can actually work it out. Then you can map it out, show the whole of the site, so that if it interferes with your works, or the people who plan the works now, the planning engineers, can actually decide what to do. Then in some instances you can perform relocation surveys. Let's say, for example, you're about to set out a building. You need to properly establish the building lines. So you might need to relocate 1 or 2 pegs. That's the part of it. That's the part of the relocation. Monitoring buildings as well. Let's say you're doing high-rise buildings or very sensitive buildings that go up, and that's are subject to movements during construction. You need to monitor those movements to see if it's deviating off verticality. Basically, it's more of a bit of deformation monitoring and verticality monitoring. So I think it's a mix. That's my own opinion. I think it's a mix. You have to see if the building is still in line, or any loading that's happening during that construction is actually affecting the building. That's another example. You can manage survey teams. Let's say you can become a survey manager or chief surveyor. So you have to manage the people you work with. You have to organize the team. You have to plan how the job is going to be executed. You have to resolve in-team disputes as well. Any problem that's with your team will be your baby. You have to sort it out so that you actually extract the maximum performance out of those people. You can manage subcontractors as well. Let's say, for example, the work you're performing, you don't have equipment for it, but you know it's cheaper to hire that service from somebody instead of procuring equipment to do it. So you subcontract survey companies, and then you do the job, and then you make sure You do the QA, QC, quality assurance, quality control of whatever they're doing, so that you probably have the best results. So, since every survey problem is your problem, the company might want to upgrade its survey technology. They might need to up it up a bit, because the level of difficulty of projects that they're getting has gone up. So you are like the first point of call in terms of upgrading survey technology, because you're the person who actually knows what you need to do the job with the quickest pace possible and the most accurate possible. So that's another point. You can do site visits as well. Some niches of projects require a surveyor to do a site visit. It'll be a team of engineers and surveyors. So you do a site visit. Some measurements you take, or some information that you gather during the site visit might actually affect the estimation of the cost of doing that project, so that when people actually price those jobs, they price them within a very reasonable range. If everything is priced in a very reasonable range, people make money and they don't make losses, which is a very important aspect in construction. In construction, you have to make money. You have to make a lot of money. Everything that you do should always give you money. No losses. No, you have to be as efficient as possible. The pricing of jobs, it's more efficient if the information of what's really required to be executed is properly distributed to the required parties. Information. So you sort out the information, the important bits from the site visit. Then you couple it with the other guy's stuff. Then you know you're good. In terms of roles, if some companies, I've noticed some companies from South Africa, there are a few companies locally who have had geomatics engineers, surveyors, setting out engineers working as site agents. It's very possible you can actually elevate to that position. So that's basically the roles and tasks of what you'll be doing on a construction site. So the key skills you need when you're working for a construction company, you definitely need to understand the drawings. You definitely need to be able to interpret the drawings. If you can't interpret the drawing, you can't do anything, because you don't know what you're doing. That's the thing. So people should research and focus more on understanding the drawing language. That's the drawing language. You should also be able to do survey control designs. So when you get to a site, of course, there are control points that are there. You're given control points by the client, or there's nothing there. You might need to create your own local system. So you have to design it properly in such a way that points are indivisible. When you set at one station, you need at least 2 points to site to. You need at least 2 points set. And the positioning of your controls as well doesn't have to affect the works, or your controls should not be in a position that they can be easily destroyed. There's a lot of excavation that happens during construction. There's a lot of demolitions that happens depending on the nature of the project. So you have to put your stuff in such a way that even if you move to another site to do a bit of work for, let's say, for a week, when you come back, you find your controls are still intact and still there. It reduces the risk of making errors just because the controls have been moved. So there's a bit of consistency when you have like solid controls, properly designed controls, and you select the materials as well. You might need concrete pegs in concrete, or you might need to drill them to the wall, and then you place your controls there. So the position where the controls are going, it's your decision. The materials, that's where the controls are going as well. It's also a decision. So when you make those decisions, you also have to put in the cost factor. You have to also be realistic in terms of selecting your material. You have to figure it out that where you are, is it possible to get stuff you need in the shortest period and within the budget as well. So there's another. So in terms of software, you when you get to a company, almost every company has its go-to software for survey, and they have procedures. Another thing, surveying procedures, they come from surveyors as well. That's another role that you take. So you might be asked to write procedures for the whole of the survey company, depending on your position. Are you a senior? Are you a manager? So you might be asked to write down a bit of procedures of how work is executed, so everything it can be homogeneous from site to site, like a uniform system for the surveys. So in terms of software, I was saying there's a go-to software. My preferred software is Civil 3D for all construction work. This is basically all survey work that I do, except for when I jump into cadastral. But most of the work that I do, I use Civil 3D, AutoCAD Civil 3D. There's a training on LinkedIn. You can get a certificate of training, essential training, certificate of completion. You just need to sign up. I think I did mine when I had a free trial, but I think LinkedIn is like $29 to $30 somewhere there. So that software, you have to master it. You have to know it back to back, so that you can efficiently plan whatever you want to do on site. You have to be able to plan. You have to be able to have like the whole view of the project using that software, so that you can properly plan. What happens is there's something called a program of works. That's like the master plan of the whole project. So you have to look at it so that you can plan. When it comes to executing a certain task, you must be prepared to do that. So preparation requires a lot of software. You use your software, then you sort it out, then you plan properly. And you should be able to make decisions as well, very, very quick decisions, very accurate decisions. And if there's need for change anywhere else, change in tactics, change in, let's say, your workforce, if you need more people, you need to be very decisive. Like, no, I need 6 more assistants right now, and then you make a plan. You move through the right channels, and then you make a plan. You shouldn't be one person who's like, I think it'll sort it out itself. You are the person who's in charge of all geomatics problems. All geomatic solutions come from you. So you should be able to make a decision real quick. And since you work as a team in construction, it's not a solo business. You should be able to communicate. So there's verbal, written communication. And then we communicate in form of deliverables. The deliverables that you plot, that you sort out from that software that I said you should master. The deliverables are the outputs of what you've plotted, what you've worked on using the software. It might be the maps for the utilities, on the topo maps. It might be long sections, it might be cross sections, it might be volumes. You should be able to communicate it to like the right party. They should understand it without breaking a sweat. So you should know your audience. That's part of communication. You should know your audience. Not everybody understands this survey business. Some people just want to see it on the ground, and then when you try explaining them and chucking in savage jargon is that they don't understand it. So in terms of communication and the deliverables, they have to like just communicate clearly. You just need to know your audience, that this person needs this simple stuff, there's less graphical. Then if you're working with people who are so into geomatics, is that a study that they have to get to. And then you have to understand the materials that you're working on as well. Let's say for example, in terms of levels, there are other processes that happen that might affect your levels. Because material on site, let's say the material used to make a road, to the concrete that's used on columns, floors, they behave differently when other tasks are performed on them. Let's say you level to the proper level, and then compaction comes through after that. It might lower your levels by millimeters that send you out of spec. So every construction project has specifications. We need plus or minus 5 millimeters above the floor. We need plus or minus 5 millimeters X and Y distance. So you have to be within those specifications. So if you don't understand how material behaves after a certain process happens, that actually comes after you have done all your stuff. Trust me, things will go south. Things will probably go south. For example, the road levels will go down, the road width will be insufficient, and then that's another problem. Rework, it costs a lot of money. Actually, no, you get into trouble for no reason. So you just have to make sure you understand the material that you're working on. If you don't know, since you're a team, like I said, construction is not a solo business, it's a team. You have to liaise with the other guys that work with the material. Then to tell you, no, just leave it a bit off, maybe 6-7 millimeters above the level, the design level. Then after the compaction, I think it'll compact it down to the actual level that you want. They can actually assist you. Like, since you don't know anything, since you don't know everything, not anything, since you don't know everything, liaise with the other guys, and then they give you information. And then when the project is good, everybody's good. Everybody's good. Everybody's happy. You get paid for good performance. You get upgrades, bonuses. You see. So that's a part of understanding the material. So the things you need to look out for when you're at construction, you need to check out drawing discrepancies. Like if there is a difference in drawings that should work together. Like there is let's say ground floor layout, reinforcement layout, and then architectural. All these drawings should have the same detail when it comes to, let's say, levels. They have to have the same detail. They have to have the same detail in terms of dimensions. That affects your XY. So if there is any discrepancy, the documents called RIFIs, or technical queries, that can be raised. That this and this doesn't add up. Can you sort us out? This and this doesn't end up. So make sure you look through all the drawings that are required for you to do your job, and then you make sure there's like homogeneity in it. The mutual elements in those drawings, they're the same. They have the same properties, everything. So you make sure that is good. There's one bit that sounds simple when you're doing it at school. When you're leveling, you're like, no leveling, it's child's play. It's just looking through this tiny scope, just looking through a ruler, a glorified ruler. That's the stuff. So, but when it actually needs to be applied, it can be very difficult. So, let's say concrete. Concrete is the most difficult thing to level. The gravels and whatnot from the roads, they're easier because you're working with machines. Machines can properly cut uniformly and everything. When you're working with concrete and then you're working with screeders and boulders, it's very difficult to get those levels 100%. Like it happens quite odd. From our opinion, road construction is quite easy. Building construction, it's something else. It's very difficult, especially that leveling part. The setting out, the holding out bolts, the setting out the columns, it's not as difficult as this. Because when you're setting out, holding out bolts and columns, as long as you get the column in the right position, and then you're using the bolts on a template, it's lacquer. It's good. There aren't many parties involved in setting out those columns. When it comes to leveling, there's you who's checking the levels, there's the guys that are screwing the levels, there's the other guys that are going to float, like power float the floor, the concrete. So the concrete goes through numerous processes, of which you have to make sure every time that process happens, everything is good. And the material used to level as well might affect how your levels come through. So leveling concrete, please pay attention to that. I'm still fighting to get to 100% when it comes to this department. Then there's also work politics. You should have very good emotional management when you're working at a construction site. There's always conflict. There's conflict somewhere, not always. There's conflict. Some days, there's good days, there's bad days. So when something goes wrong, you might have set out correctly, but something just happens that's not on your part. Usually when something goes wrong that's related, even if it's not you, it becomes your baby. So you have to manage your work politics so that everybody works on the same page. It's very important, that part. So your work politics, generally you have to be in good relations with everybody. Not necessarily be friends, but you have to be a very good workmate. I think generally every job you have to be a very good workmate, so that you move as a team. You don't move as separate parties. Because if you do your leveling and then this other guy comes and gives other instructions, everything goes south. When it goes south, if it's a geomatics problem, like I said, if it's a setting out leveling problem, it becomes your baby, of which you're the person to blame at that moment. So those work politics, you have to. Then all data that you work on, all the the control designs, the setting out data that you create using the software, please back it up. You have to back it up. Work machines also die. They also total stations that you check in the data they might be at fault, then they need to go to get fixed. It might take long, of which there's data there. So every time you do a job, please back up your data. Back it up somewhere. Back it up in your computer, back it up in your cloud drive. Your computer as well, it might crash. Anything might happen. So you have to have multiple streams of backup. And then one important part, I think this is the last one. You have to avoid doing things that are out of scope. When I say out of scope, it's not on the design, it's not on the drawing, or it's from a verbal instructions. There are cases where people dish out verbal instructions and then they deny it. Later on, they say, I didn't do this. And of which you would have done the job. You would have set it out. Concrete pinda. Then they say, demolish. Of which it's not a good record that you had a site and then there are demolitions on your account. We get paid to be accurate, so we have to be accurate as possible. So avoid working things that are out of your scope or from verbal. If it's on a drawing, you can quickly defend yourself like, no, this is on the drawing. I've put it as is. If I failed to put it as is, of course you have a case, but if not, you don't have anything on me. You don't have anything on the company, because if there are demolitions that cost the company because a construction company, which is not part of why you get employed, to give people stresses about losses. Nah, you get paid to sort out things, come out accurately. The quicker you are, the more accurate you are, the quicker the project goes. The more money you make, like I said, you get bonuses and whatnot, and reputation as well. You might get reputation. You never know the people you work for. They might be interested in you. They say, this is a very good guy. How about we give him a better offer than what he's getting? So you make a name for yourself. No shikadzira sita ne basa pachishona kuti mabasa emaoko ako ndo anoonekwa. So that's how life is in construction. So make sure you master your softwares, you understand your setting up. Another thing, you have to be highly adaptive to the machines that you get. It's not every company that can afford to buy Trembles, Lakers. Some of them have Goins and just all those Chinese brands. So every time you get a new machine, please look through the manual so that you properly understand it. If the new machine is out of spec, let's say you're given a 20-second total station when you're working on a building, that's not proper. You need maybe a 2-second machine. So if there's a problem with the machines that might affect the accuracy of the project, please flag it. Everything that's wrong, flag. That's how we work in construction. So I think this is all for this episode. Please tell your friends to subscribe. Keep on sharing the links. Mask up, COVID is real. And thank you.